Students, today class electromagnetic waves. Now this is a unit 6, second lesson electromagnetic waves. Example electromagnetic waves, example gamma ray, X-ray, UV ray, visible, infrared rays, microwaves and radio waves. What is the source of electromagnetic waves? This is one more question. What is the source of electromagnetic waves? The accelerated charged particles which produce electromagnetic waves. So the accelerated charged particles are the source of electromagnetic waves. Now here electric field E taken along the x-axis, magnetic field D taken along the y-axis. Now electric and magnetic field are mutually perpendicular to each other. Then the electromagnetic wave propagated perpendicular to the direction of electric and magnetic field. So draw the electromagnetic wave structure. This is the diagram. Now E is the electrical field taken along the x-axis. B is a magnetic field taken along the y-axis. Electric and magnetic field are mutually perpendicular. So after electromagnetic wave propagated perpendicular to the direction of electric and magnetic field along the z-axis. So now E is an electrical field, B is a magnetic field. What are the important properties of electromagnetic waves? Properties. What are the important properties of electromagnetic waves? This question is very important. Your examination question, 2-mark question. Mention any two properties of electromagnetic waves. The first property, electromagnetic waves are transverse waves in nature. Is very important point, this one. Electromagnetic waves are transverse waves in nature. Sometime one more question. What kind of electromagnetic waves in nature? Answer, transverse waves. Now students, here the first point, electromagnetic waves are transverse waves in nature. And second property, the accelerated charged particles which produces electromagnetic waves. The accelerated charged particles which are produces electromagnetic waves. And point 3, the speed of electromagnetic waves. So the speed of electromagnetic waves C equal to 3 into 10 power plus 8 meter per second. The speed of electromagnetic waves C equal to 3 into 10 power plus 8 meter per second. All electromagnetic waves have same speed but different wavelength, different frequencies. So the third property, the speed of electromagnetic waves C equal to 3 in 10 power plus 8 meter per second. And fourth property, electromagnetic waves carry energy and momentum from one place to the another place. So these are very important properties. These are very important points for properties of electromagnetic waves. The first property, electromagnetic waves are transverse waves in nature. Second property, the accelerated charged particles which are produces electromagnetic waves. And point 3, the speed of electromagnetic waves C equal to 3 in 10 power plus 8 meter per second. Electromagnetic waves carry energy and momentum from one place to another place. And one more important property, electric and magnetic field are vibrate or oscillate with same phase along the direction of propagation of wave. These are important properties of electromagnetic waves. So after who confirmed electromagnetic waves experimentally? This is the one more question, friends. This is the one more question. Who confirmed electromagnetic waves experimentally? The name of the scientist, Henry Childs. Who confirmed confirmed electromagnetic waves experimentally. Experimentally first demonstrated the familiar scientist Heinrich Hertz. This is a 1 mark question. Who confirmed electromagnetic waves experimentally? So answer Heinrich Hertz. Who explained electromagnetic wave theory? Maxwell. So Maxwell's. Who explained electromagnetic wave theory, or who predicted electromagnetic wave theory? Maxwell. Who experimentally confirmed electromagnetic waves? Heinrich Hertz. Is very important your examination point. Heinrich Hertz experimentally confirmed electromagnetic waves. Theoretically explained on the basis of Maxwell's equations. So Maxwell explained electromagnetic wave theory. So after write the expression for the speed of electromagnetic waves travel free space in air and vacuum and explain the symbols. This is the 2 mark question. Is very important question. Write the expression for the speed of electromagnetic waves travel free space in air or vacuum. The mathematical formula C equal to 1 divided by square root mu naught into epsilon naught. Is very important mathematical formula. C equal to 1 divided by root of mu naught epsilon naught. This is a 2 mark question. Write the expression for the speed of electromagnetic waves and explain the terms or symbols. So C is the speed of electromagnetic waves. 1 divided by square root mu naught epsilon naught. Mu naught is a magnetic permeability of free space. So that value 4 pi 10 power minus 7 Henry per meter. Epsilon naught is a electric permittivity of free space. So epsilon naught value 8.854 10 power minus 12 in electrostatics. So now substituting for mu naught and epsilon naught value, then finally get value C equal to 3 into 10 power plus 8 meter per second. Students, you observe here very important mathematical formula. So last year in March examination, this is the 2 mark question. Write the expression for speed of electromagnetic waves travels in a free space and explain the terms. So now C equal to 1 divided by root of mu naught epsilon naught, where mu naught is a absolute permeability of free space. So that value mu naught value 4 pi 10 power minus 7 Henry per meter. Epsilon naught is the electric permittivity of free space. Now substituting for mu naught and epsilon naught, finally you get value C equal to 3 10 power plus 8 meter per second. This value is the speed of electromagnetic waves. What are the importance of speed of light? What are the importance? Or mention the importance of speed of light. The speed of light is value used to calculate the refractive index of the medium. So now formula n equal to C by V. Mention the importance of speed of light. The first importance means the speed of light is value used to calculate the refractive index of material of the medium. So n equal to C by V. N is the refractive index. C is a speed of light in free space, air or vacuum. V is the velocity of light in medium, maybe glass, denser medium. So this is the first importance. Second one, this value used to calculate the frequency of electromagnetic waves. The frequency of electromagnetic waves nu equal to C by lambda. So nu is the frequency, C is a speed of electromagnetic wave, lambda is a wavelength. So nu is the frequency of electromagnetic waves, lambda is a wavelength. Now you are observing 2 points here. mention the importance of speed of light. So the first one, speed of light used to calculate the refractive index of material of the medium. The refractive index of the medium calculated as using formula n equal to c by v. Now, the frequency of electromagnetic waves can be calculated as the formula nu equal to c by lambda. So now you observe, friends, here important mathematical formula. The speed of the electromagnetic wave c equal to 1 divided by root of mu naught into epsilon naught. Mu naught is a permeability of free space. Epsilon naught is a permittivity of free space in air and vacuum. The speed of light, speed of electromagnetic waves c equal to 3 in 10 power plus 8 meter per second. Friends, there are two important definitions here. One is a conduction current, another one is a displacement current. In our examination, it is very important, a 1 mark or 2 mark question, conduction current, displacement current. Now, conduction current, a current carrying conductor, and this is the conductor, I is a current, this arrow mark indicate direction of flow of current. The electric current carried by the conductor due to a flow of electric charges is called conduction current. It is very important statement definition for electric conduction current. The electric current carried by the conductor due to a flow of electric charges is called conduction current. Conduction current which obey Ohm's law. So V equal to IR. Conduction current which obeys Ohm's law. So V equal to IR. Now conduction current symbol IC equals V by R. Conduction current symbol I, we mentioned C. So IC which represents conduction current equals V by R. So friends, one more time we repeat. What is a conduction current? The electric current carried by the conductor due to a flow of charges is called a conduction current. It obeys Ohm's law. V equal to IR. Then conduction current IC equal to so V by R. And one more important displacement current. The electric current due to changing electric field or changing electric flux is called displacement current. The mathematical formula ID. ID is a displacement current. ID is a displacement current. ID equal to epsilon naught d pi e by dt. This is very important mathematical expression for displacement current. Sometime 1 mark question also write the expression for displacement current. So ID equal to epsilon naught d pi e by dt is a very important mathematical formula. Displacement current ID equals epsilon naught d pi by dt. So every in examination also, board examination, 1 mark or 2 mark question, what is the displacement current? Write the expression for displacement current. The electric current due to changing electric field or changing electric flux in a given time is called electric displacement current. So displacement current formula ID equal to epsilon naught d pi by dt. So ID, this symbol represents displacement current. Epsilon naught is a permittivity of free space. D pi by dt is the rate of change of electric flux, the rate of change of electric field. This is a very important concept in 1 mark or 2 mark question. Conduction current, displacement current. So conduction current, the current carried by the conductor due to a flow of electric charges is called a conduction current. Mathematical formula IC equal to V by R. Displacement current, the electric current due to changing electric field or changing electric flux is called displacement current. The mathematical formula ID, this symbol represents displacement current. So ID equal to epsilon naught d pi by dt is very important your examination point. Write the expression for displacement current ID equal to epsilon naught d pi e by dt. Now the next concept, state Ampere's Maxwell law. Already you know the Ampere circuit law, unit 4, moving charge. Ampere circuit law used to calculate magnetic field due to current carrying conductor. According to the statement of Ampere circuit law, the line integral of a magnetic field around any closed conductor is equal to mu naught times the total current passing through the conductor. The line integral B dl, the line integral B dl equals mu naught I. The line integral of magnetic field around any closed conductor or any closed surface is equal to mu naught times the total current passing through the conductor. This is the statement of Ampere's circuit law. But now here state Ampere's Maxwell law. So according to this law, the total current passing through any surface which is a closed loop is equal to sum of the conduction current and displacement current. So total current I equal to sum of the conduction current and displacement current. So I equal to IC plus ID, where IC is a conduction current, the current carried by the conductor due to flow of electric charge is called a conduction current. ID is a displacement current, the electric current due to changing electric field or changing electric flux is called displacement current. So displacement current formula ID equal to epsilon naught d by e by dt, d pi by dt. Students, now you observe a very important mathematical expression. The first one is the Ampere circuit law. So after second equation, state the Ampere's Maxwell law. The total current passing through any surface which is a closed loop is equal to sum of conduction current and displacement current. Now I equal to IC plus ID, where ID is a displacement current. The mathematical expression for displacement current ID equal to epsilon naught d pi by dt. Now you write the Ampere's Maxwell law. So now Ampere's Maxwell law, the line integral B dl equals what? Mu naught. Mu naught. So I equal to what? IC plus ID. IC plus ID. But ID equal to what? Epsilon naught d pi d by dt. d pi by dt. Write the mathematical expression for Ampere's Maxwell law. So the line integral BDL equal to mu naught into IC plus displacement current what? Epsilon naught d pi by dt. So this is a 2-mark question. State Ampere's Maxwell law and write the mathematical expression. The total current passing through any surface which is a closed loop is equal to sum of conduction current and displacement current. So displacement current ID equal to epsilon naught d pi by dt. So finally this formula, line integral BDL equal to mu naught into IC plus epsilon naught d pi by dt. This is Ampere's Maxwell law.